All right, in the top right-hand corner it says Chapter 7, Rational Functions. What does the word rational mean? Or what does the word irrational mean?
I think like it can be a fraction or something.
Great, Jules. Excellent. Rational means a number that can be written as a fraction. Irrational means a number that can't be written as a fraction. So rational functions, when you guys hear the word rational the rest of this chapter, it basically means a fraction. All right? So our goals, our objectives today, well, first, you notice we're starting at 7.3. That's a little bit different. We're going to come back to 7.2. We're not going to do 7.1. 7.2 is over graphing rational functions. I'd rather do that at the end of the chapter when it's closer to the test. Okay? So our goals today are going to be able to simplify rational expressions and then multiply and divide rational expressions. And again, whenever you hear rational, it basically means fraction. Now, rational expressions, what are they? Well, I just said fraction. Well, the more appropriate definition is an expression of the form r of x equals, guys, I say r of x because r represents rational. It's just a function. I could have said f of x if I wanted to. All right, I'm going to say r of x to let you know it's a rational function, where it's going to be p of x over q of x. Where p of x and q of x are polynomials. Where q of x cannot equal 0. Okay, so I've got this function, p of x over q of x, and it says that p of x and q of x are polynomials. Again, polynomial is a number, a variable, or a number times a variable, or multiple of those, meaning added together. Okay, polynomials where q of x cannot equal 0. Guys, we can't have 0 in our denominator of a fraction because we can't divide by 0. So we always have to keep that in mind in this chapter, is that our denominator can't be 0. Okay? So essentially, if I look at example 1, we have polynomials in the numerator and polynomials in the denominator. Okay? As a fraction. So example 1 here, it just says simplify, meaning we want to just simplify, get it in the simplest form. Okay, let's look at the second one first. First of all, I forgot a parenthesis there, so correct me. Now, you notice, I guess, what's different between the second one and the first and third one? What's different about the second one? Okay, there's a number in front of the parenthesis. I agree. What else? Ryan?
In the second one, that has x plus 1 and x plus 3, which we make the first one have that output.
Okay. Yeah? You're on the right track? Yeah, there's 2 of them. Would you guys agree that the second one is factored?
Yeah.
Does that make sense? The first and the third one are in factored form, but the second one is factored. So if it's already factored, we can go ahead and try to simplify. Now we know if something's in the numerator and something's in the denominator, we can cancel. All right, so if I look here, would you guys agree that x plus 1 is in the numerator and the denominator? So we're going to cancel those out. Gone. So what am I left with? I'm left with 2 times x, or excuse me, 2 over x plus 3. Okay, so we want to factor, and then we want to cancel. Now, what value of x, or I should say, what value can x not be?
0.
I'll say this. I'll rephrase my question. What value of x will make the denominator 0?
It has to be greater than -3.
Would you guys agree that -3 would make the 0 in the denominator? Okay, so we need to put this little condition on here where it says x cannot equal -3. Because if x was -3, I would get 0 in the denominator, and I know I cannot divide by 0. It's undefined. So we call this our undefined value. Okay, we just need to tag that onto the end of all of our problems.
Can I
answer, guys. We're done with it.
This whole thing is the answer. Yep, we've simplified that rational expression. Okay, going over here. Now, we need to factor. Now, there's my disclaimer. If we struggle factoring, this chapter is probably going to be a nightmare. Okay, we need to factor. So I look here and say, all right, well, what are factors of negative 12 that add up to negative 4? If you need to do this, that's fine. Remember, I can mini-marf here because there's a 1 there. So factors of negative 12 that add up to negative 4. 6 and 2, which one's negative? I think the 6 because that's negative, right? So I'm going to call that x minus 6 and x plus 2. And then does the denominator factor at all?
No. It's not typically. No.
What's this called again? What, Alyssa? Yeah, difference of squares. If this is a perfect square, and that's squared, and that's a minus sign, it's going to be x plus 2, x minus 2. Difference of squares. Okay, now can we simplify this? We can. I can take x plus 2 out. And so here I'm going to have x minus 6 over x minus 2. Now x cannot equal what? 2. And I'm actually going to go back. Let's go back to this one for a second. Guys, we want to look at both of those. But even though we canceled one, we still need to incorporate that. So I guess this was my mistake over here. We should have negative 3 and negative 1. So we always want to go back to the form that was completely factored. So if I look at this, we completely factored that. What values are in the denominator? Or I should say, what values would make the denominator 0? 2 and negative 2. So you could say a couple different ways. You could say x cannot equal plus or minus 2 because that would make the denominator 0. So always look at the complete factored form, and those are our values that x cannot be. Those are our undefined values. Say it again. Because if I plug this in, it's a great question. If I plug negative 2 in here, what's negative 2 squared? That's 4. 4 minus 4 is 0. We don't want 0 in the denominator. Okay, here we go. Let's factor the numerator here. Factors of negative 3 that add up to negative 2. Negative 3 and positive 1. And x factors of negative 6 that add up to negative 1. I think that's negative 3 and positive 2. Would you guys agree there? Now, what's going to be our condition here at the end? Our undefined values. I know x can't equal 3, comma, x can equal negative 2. And then x minus 3's will cancel, right? So my final answer should be x plus 1 over x plus 2. But we need to know that x cannot equal 3 and negative 2. Questions there? Okay, guys, I messed up on example 2 here on the first one, so fix this for me. This needs to say times 7x to the 4th y cubed over y to the 4th. Guys, we've done problems like this before. Okay, this isn't new. We've covered this before, where we need to just simplify this. Now, I like to just combine them first, kind of like we did over here. I multiplied them first and then I simplified. Well, I'm going to multiply and then I'm going to simplify. So if I look at multiplying my numerators together, 8 times 7 is 56. X to the 3rd times x to the 4th is what? Peyton, what's x to the 3rd times x to the 4th? Great, x to the 7th. Y times y cubed there, Owen? Y to the... There's a first there. What do we do with our exponents? 4. Yep, we need to add our exponents. And then in my denominator, I'm going to have 2 times 4, which is 8. X, well, there's just an x there. And then y squared times y, Jesse's what? Y to the 3rd. Are there questions on doing that? Okay, now I can go ahead and look to simplify. First of all, I need to look in my denominator now. What values of x and y can't be? What value of x can't it be, right? Not sure. What value of x would make the denominator 0? Say it again. No? I think 0. If I plug 0 in here, 8 times 0, aren't we multiplying all three of these things? Okay, so if x is 0 and I multiply by 0, that's not good. Same thing with y. If I plug in 0 for y, I'm going to get 0 in my denominator. Okay, so when I simplify this, in the end, I'm going to move it over here. In the end, I need to say that x cannot equal 0 and y cannot equal 0. Okay, so now I can simplify. What's 40 or 56 divided by 8? That's 7, right? Now I have x to the 7th and over x. Well, I can cancel this 1x with 1 there to make this a 6, right? So this would be x to the 6th. And then my y, I can cancel 3 y's there with 3 of them there to make that y to the 1st. So our answer then is 7x to the 6th y, but x and y can't equal 0. Questions on that one? Awesome. Now we get over to this next one. A little bit more complex. Here's our rule, guys. We want to factor whenever we can factor. Okay? We want to factor. So if I look at this numerator, looks kind of goofy because our x squared is our second term, but what's in common between 3x and negative 3x squared? And isn't there a 3x there? So I can factor out a 3x, and I'm going to be left with 1 minus x squared. Oops, excuse me, 1 minus x. If I factor out a 3x out of here, I'm going to have 1 minus x. And if I factor my denominator, factors of negative 5, that add up to 4. Say it again. Negative 1 and 5. So this is going to be x minus 1 and x plus 5. Same thing over here. Factors of 20, negative 20, excuse me, that add up to 1. I think that's x plus 5 and x minus 4. And then lastly, we just have a 3x here. I've factored everything. All right? Now I can go ahead and start canceling. Now, I'm going to, before I cancel, guys, I'm going to look at my denominator. What values can x not be? X can't equal 1, negative 5, 0. Now we can go ahead and cancel. I'll cancel my... Are these the same? They're not, are they? Oh, shoot. X minus 1 is not the same as 1 minus x. But if I have 1 minus x, and I switch these, because I wanted this to cancel, ideally. and I switch those, I got to take this sign in front. So I'm going to call this negative x plus 1 because there's a positive sign there. Now, is negative x plus 1 the same thing as x minus 1? I don't think so. Not quite. Not quite, because this is x minus 1 and this is negative x plus 1. What would I have to do to this to get it to be x minus 1? Okay, Trail said divide by a negative. Or could we just factor out a negative? Yes? No? If I factor out a negative out of this, negative 1, I'll just factor out a negative. I get x, take a negative out of a positive, that's minus 1. Now do I have x minus 1? I do. So I'm going to replace this with x minus 1. I can't forget that negative sign though. Where should I put that negative sign at? I could put it here, but that looks like minus. I should probably put it way out front. So I've replaced 1 minus x with negative 1 times x minus 1. They're the same thing. Now, what does that allow us to do? That allows us to now cancel our x minus 1s. We couldn't do that before we did that. And I can cancel x plus 5s. Can I cancel anything else? Easton, can I cancel anything else?
Did you do the 3x?
Oh, I got negative 3x there and 3x there. Can I cancel those? Guys, if I had negative 3 x over 3x, can I simplify that? I'm just being honest here. When I was in your guys' shoes, I got really confused here. Because is the negative 3 with the x or not? It's negative 3 times x over 3 times x. Well, I can cancel my x's. I can cancel my x's. And can I reduce negative 3 and 3? Yeah, I can take a 3 out of everything. Okay? So yes, I can cancel that x with that x. And that 3 with that 3. But we need to remember there's still that negative around. So what do I have left? I've got a negative. I have x minus 4. Oh, and that's it, right? I don't have anything in my denominator anymore. Okay, so let me just rewrite that. I've got negative times x minus 4. Now, I don't know. We're not going to do this in the computer, this lesson. We're going to do this on paper. But I think this is the same thing if we distributed it through and had that. I would accept either one of those. Questions here? Guys, this whole deal that I had to do over here made this problem a little bit unique. But big idea, factor everything, cancel whatever cancels. Okay, let's go down example 3. Now, guys, when I type this into the computer, when it's a fraction, it makes it into a smaller font, okay? Just because this is a smaller font and that's a bigger font, that doesn't matter. But how are we going to do this? Great, absolutely. This is over 1. So now I have 2 fractions. One just says bigger font here. So now I'm going to factor everything. So when I factor this, I'm looking for factors of negative 28 that add up to 3. So what are those? Well, figure it out. What is it? Negative 7 and 4?
Or 7 and negative
I like 7 because this is positive, so x plus 7 and x minus 4. Luke, how do we factor x squared minus 25?
X minus 5, x minus 5.
You're close.
X minus 5, x plus 5.
Yep, x plus 5, x minus 5. Times, this is going to be over 1. Factors of 15, Ryan, that add up to negative 8. Negative 3, negative 5. Great. X minus 5, x minus 3. So now, I always like to take a look and say, hey, what values can x not be? Well, negative 5, 5. I guess that's it. And now I can go ahead and cancel. X minus 5's cancel.
Why don't we have to do anything with the 1 on the 2?
Because there's not an x there. That means because we're looking, hey, what values of x? There's really not an x there, so we can't do anything with it. Anything else cancel? Okay, that's possible. It's possible. So this is going to be x plus 7, x minus 4, x minus 3, all over x plus 5. Questions on that at all? Hang with me. I know this is getting a little lengthy. Back page. Dividing. Now, in our bell ringer, when we divided these fractions, didn't we just multiply by the reciprocal? I don't want to divide. I want to multiply by the reciprocal. Okay? So if I multiply by the reciprocal, and I get a question that says, which one do you switch? Does it matter which one you flip? And I think, yes, it does. Because 12 divided by 3 and 3 divided by 12 are completely different, right? So we need to keep that in order, and we need to multiply and flip the second one. So I'm going to rewrite the first one. I'm going to say 7x over 2x minus 10 times the reciprocal. So I'm going to put x squared minus 11x plus 30 in the numerator and x squared minus 6x in the denominator.
How can we only flip one side?
Because if I go back here, okay, so now I need to factor. So I got 7x, that doesn't factor. If I look at 2x minus 10, does that factor? Maddie, does 2x minus 10 factor at all? What can we factor out? A 2, yep. So I'm going to factor out a 2. I'm going to have x minus 10, or excuse me, x minus 5, times. Chris, does this denominator factor at all? Can we factor anything out? What's in common between x squared and 6x? Is there an x in common? So we can factor out an x. So I'm going to be left with x minus 6. My numerator there, Jules, what are factors of 30 that add up to negative 11?
15 and negative 2.
Those don't add up to 11, negative 11. Yeah, what about 5 and 6? Negative 5, negative 6, would that work, Jules? So we're going to have x minus 5 and x minus 6. Okay, so x cannot equal what values here? 5, 6, and we need to remember that one, 0. Because if that's 0, everything's going to be 0. Okay, now I can go ahead and start canceling. X minus 5, x minus 5, x minus 6, x minus 6, this x and that x. So now in my numerator, I get 7 over 2. That's it. 7 over 2. Questions there? Okay. Guys, this one is a dandy. All right. And I honestly, I probably won't give you too many of these just because of the amount of work that's involved. But if you notice this, all of these have an A value, don't they? So instead of mini-marfing, we have to marf, which can get lengthy. Okay? So what I'd tell you is I'm going to do these on the whiteboard over here. I want you to do these at the bottom of your paper because this is going to take quite a bit of room here. Gosh, all that factoring, I mean, what a great way to start your Friday though, isn't it? Oh, Maddie? Yeah. Okay, so we did all this factoring. I'm just going to rewrite it down. So this top one here is 2x minus 3 and x minus 2. You guys let me know if I make a mistake. My denominator was 2x plus 1 and x minus 2 times, because remember, this is a division problem, but I want to multiply by the reciprocal. So 2x plus 1, does that factor at all? No, so 2x plus 1. And then my denominator now is 3x minus 1 and x plus 2. Okay, so before we start canceling, we need to figure out which values can x not be. So I think this is easy. X can't equal what here? X can't equal 2 and x can't equal negative 2. So x cannot equal, I'm going to call that plus or minus 2. What about this guy though? Guys, remember, when we set these equal to 0, this is easy because there's not a number here. This is not so easy. Our shortcut is the opposite of this number divided by this number. So this would be negative 1/2. Why does that work? Don't write this down, but just watch me. If I set that equal to 0, guys, and I'm solving for x, minus 1, I get 2x equals negative 1. Divide by 2, negative 1/2. So if there's a number there, take the opposite of that number, divide by that number. So then I need to do the opposite of this number, which is 1, divided by that number, 3. So we have 4 values that x essentially cannot be. All right, so if I look here, what cancels? X minus 2 does. 2x plus 1 does. And that's it, right? So my final answer should be 2x minus 3 divided by 3x minus 1 and x plus 2. And our undefined values are positive and negative 2, negative 1/2, and 1/3. Guys, we're not going to do this last one. I'm just going to kind of talk you through it. So when I was multiplying, guys, this was over 1, right? But now I'm dividing. It's still over 1. What, Jesse? Yeah, so when I multiply, I need to multiply by the reciprocal. So we're going to put 1 on the top because we're going to flip it. And now we're going to do the exact same thing. We're going to factor and we're going to cancel. Okay? I want to talk about two things. Two things and I'll cut you loose. Let's say I had this. I had, let's do 8x cubed over 4x squared minus 5x. It's on the assignment. Just cancel. What do we do here? Here's the rule. Before you cancel anything, factor. What factors? Does the numerator factor? No. Does the denominator factor? I think there's an x in common, right? So if I take out an x, I'm going to have 8x cubed in the numerator, and I'm going to have I'm going to factor out an x. So now I'm going to have 4x minus 5. Now what cancels? Just the x there with 1x there to make that 0. Okay, so my final answer here should be 8x squared over 4x minus 5. Now, x cannot equal what? Positive 5 over 4 and 0. Guys, I see this a lot, and this is wrong. I see, oh, there's a 4 there. I'm just going to cancel. Oh, there's an x there. I'm just going to cancel. Okay? Or if I have x squared plus x, I'm just making this up, plus 6, and x squared, let's say minus 36. I say, oh, there's a 6 here. I can just cancel those and make... That does not work. Okay? We have to factor any time and every time we can factor.